So if we're off our throttle and we're below 1% throttle here, just so we're very clear, so user demand minimum below 1%, we're in the zero demand spark timing table. That's our base spark timing we're going to command. That's going to be essentially between the airflow coming into the engine that's fixed from the throttle blades and the spark timing we're commanding from the zero demand. That's what's going to make up our idle torque. We can further refine our idle torque and therefore further refine our idle speed if we go in here and we take a look at our engine functions into idle control, and that's going to be our, let's jump in down here, ignition correction table. This is going to take a look at the idle control RPM error. So this is going to be looking at where our desired target idle RPM's at. I set that to 1200 here on the warm temperature. So 1200 RPMs where I'm expecting to idle with this. That's pretty reasonable for a really large set of throttle bodies like this. I'm probably not going to try to go any lower than that, but 1200 is what I'm going to put in here. And this is going to look at if we're under or over that amount of idle RPM. So if we're at 1400 RPM, well, in that case, we're going to be here at our positive values. If we're at, let's say, 1000 RPM, we're going to be below that in the negative values. This is going to allow us to add or subtract spark timing to our zero demand spark timing value to further influence our engine's torque output and further refine our idle control. So when we have individual throttle bodies, or even if you deleted the idle control motor, you can set your minimum airflow or your base airflow from your throttle stop on your throttle bodies or throttle body, and then you can use your spark timing feedback to manipulate your idle torque to get to your desired idle speed. The best thing to do, in my opinion, is to have a little bit of surplus of airflow, a little surplus of torque, and use the spark timing to reduce that torque down to get to the desired idle speed. And when you're decelling back into idle, you'll find that you're not immediately into the zero demand table and your ignition timing feedback's not going to turn on and start to reduce the timing down. That's going to give you more stable return down into idle, having a little bit additional airflow, having a little bit additional torque reserve on any engine, especially race engines. I always do this because they typically don't have idle control motors. So the idea here of airflow and spark timing hopefully makes sense, and the influence they have on engine's torque. And essentially, again, what we're trying to edit is the engine torque, but we're going about it either airflow or spark timing based. Again, I have the minimum airflow set with our throttle blades. It may not be enough. We might have to turn it up. We'll have to see how that goes. Now, if we adjust our throttle set screw, you need to go in and make sure anytime you're adjusting the set screw that you're coming in and immediately adjusting your throttle position sensor scaling again, because it won't track that 0 to 100, specifically the 0 off throttle, won't track that correctly, and then it can kick you out of idle control and you'll be chasing that and it'll be a mess. So just make sure if you're adjusting the throttle stop, go back in and adjust your throttle position sensor. Very, very important, especially with an alpha end strategy that references throttle position to get your engine to fire off. What I'm going to do on this table is actually simplify this table a little bit and just get rid of our RPM derivative, and we're shrinking it down here. So it's purely taking a look at idle control RPM error. I'm going to say if the error is going to be overshooting high, I'll take away as much as 10 degrees of timing here. If I'm at 20 degrees, 300 RPM over, we're going to take away negative 10 degrees. If we're at 20 RPM over, I'll say we'll take away a negative degree. And then between these two, we'll do L. And the same thing here. If we're going to be going and dropping below the desired idle speed, I'll say we'll add 3 degrees of timing. And if we're 300 RPMs below, we'll add 12 degrees, linear interpolate between these, and now we have a table that's ballpark. This is going to be adding and subtracting timing constantly to the zero demand ignition timing value we have. And what I'm going to do to the zero demand real quick is bump that up just slightly and not have it at something like 7 degrees. Have it at something like maybe 10 degrees to start off with here, and then we'll feel that out. Now, if it gets down to 700 RPM, we'll put it at 25 degrees, 800 RPM, 20 degrees, 900 RPM, we'll do 15 degrees. We'll just kind of be more aggressive with the timing, trying to ramp up the idle torque. So the idea here is if the idle speed starts to drop too low, it'll go in and it'll generate some more idle torque, and by having more spark advance and push that idle speed back up. So this table here will be our basis. The feedback will be allowing us to go in here and allowing us to make those fine adjustments in the idle torque and then therefore the idle speed. So hopefully all this makes sense. Let's go in here and do another save real quick, and let's jump back in here to fuel tuning, and we should be ready now to fire up our engine. Now, one more thing I want to mention here before we fire up our engine. The engine is cold. So we have two different factors going on here that we have to keep in mind when we're trying to look at what the fueling is doing and how the engine.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.